Okay, we said we were going to do this, so I guess we should actually do it. So the review from Friday, let's go over the questions. Number 1, which function shows the data in the table below? So we look at our change in x is pretty constant, +1 all the way down. We look at our change in y, or f of x, we have +9, +9, +9 all the way down. So that means our slope is always going to be 9 over 1. So it's either going to be A or C. So then we look at, are we going to have an intercept here? So if we just try our first one here, if we say 9 times 1 should equal 11, but it doesn't, so we need to add something to it, so we get +2. So our answer to this one is just C. Okay, nice and easy. Number 2, calculating your heart rate. What's her face subtracts her age from 220, then takes 70% of the difference. Which equation should she use to calculate that? So she subtracts her age from 220. So that's going to be 220 minus her age. And to take 70% of something, that's to multiply. You can't multiply a percent, so we turn it into a decimal, so that's going to be times 0.7. Do we have an answer that looks like that? We do. And that's it. The only thing you might have been confused by is maybe if we did A minus 220. But if you think about that, if her age is anything less than 220 years old, this would end up being negative, and that would mean she had a negative heart rate, which would be amazing, but inaccurate. So sometimes if you're not sure, you can use the wording of the problem to help you out. Okay, so that's that. 2 down, some more to go. This one here, I think this one, the instructions said simplify. I don't know, hopefully. So we're going to do what we can, so we're going to distribute first. So 2 times 7x, that's 14x. 2 times negative 2y is negative 4y. Plus 6x, that's just by itself. Negative 7 times x is negative 7x. And negative 7 times negative 3y is positive 21y. Alright, so we combine our like terms here. We've got 14x, 6x, and negative 7x. That's going to be 20 minus 7, which is 13x. Take our y's here. We have negative 4 plus 21. That's going to be positive 17y. That's D. Not so bad. Not so bad. Number 4. This is a lot like number 1, except this one's a little bit different in that we have +1 here, but we have +2 there. So we're going to have to work a little bit more. So this over here, +2, +4. So our slope for this first one is going to be 2 over 1, which is equal to 2. Our slope for the second pair is going to be 4 over 2, which also equals 2. So we do have a linear relationship here. Our slope is going to be 2, so that's going to be 2 times the distance. Again, we just check it. So if we check this very top one here, if the distance is 3, we have 2 times 3, and that's supposed to equal 10, but 2 times 3 is 6, so we need to add 4 to that. So we get 2d plus 4. Okay. Number 5, total number of miles Raul runs is that equation. Ben runs at this other equation. If t is the time, which statement best compares their speed? So speed, the only thing we look at is this rate per hour. That's speed, right? So Raul's running 6, I guess we can call that miles. That's, yeah, miles. Yeah, miles, 6 miles per hour for Raul. Ben is 5 miles per hour, which means Raul is faster by 1. That's it. So this is just a little bit of reading. Okay. Number 6, Richard works at an appliance store. That's his equation. Daily earnings is y based on selling X appliances. Which is the slope Well, slope, if this is a regular linear equation, then slope is always just the coefficient of x. So it's 25. So let's look at our answer. So total amount of money Richard earns every day. The total is going to be y. The number of appliances he sells, that's x. It tells us that. The amount of money he earns if he sells no appliances. So if we have 25 times 0 plus 56, he would have earned $56. So the amount of money he earns if he sells no appliances is this 56, or B. If we wrote this out in y, mx, slope intercept form. Which leaves just J, the amount of money he earns for each appliance, that is this rate of 25. So our answer is J. Okay, 25, this is M, the slope. So far, so good. Alright, so this one some people are asking about because they're like, oh, we never did this. Well, this one is more just a thinking question. You got to think, what does this really mean? So we have 5 times this quantity, right? And this quantity. We're adding them. So we're saying, what's 5 times square root of 2y plus the square root of 2y? And we've talked about this example. We talked about it with cats. If we're multiplying this, and it's the same thing over here, all this is this doesn't really matter. This could be 5 cats plus 1 cat. This would be 5 cookies plus 1 cookie. But in this case, it's 5 square root of 2y's plus 1 square root of 2y's. But regardless of what it is, and the square root's a little scary, I'll admit, but you don't have to think about it that much. If you just think of this as 5x plus x, and we just say x equals the square root of 2y, right? This just works out to 6x. And then if we put x back to what it is, we get 6 times the square root of 2y. See, not so bad. There's your answer. Okay. Number 8. I always like these questions. A light year is this far? It's pretty far. Andromeda galaxy is about that many light years. How many kilometers is the galaxy from Earth? So this is saying, and let's simplify this down in case you're not sure. Let's say this is, what's the question? Oh yeah, let's say this is 2 kilometers. And let's say, and that's 2 kilometers per light year. Just for fun. And this one says it's this many light years from Earth. Let's say that's 10. Right, 10 light years. So if it's 2 kilometers per light year and you have 10 of them, then you'd say, well, what's 2 times 10? And you get 20, right? That's the basic idea, except we don't have nice numbers. We have this number and we have this number. But we're still just multiplying. So we have 9.46 times 10 to the 12th times 2, times 10 to the 6th. All right? And then we just multiply out. You could change this into standard notation. I wouldn't do that. That's kind of would be a pain. So we get 9.46 times 2, and we're going to get 18.92. And we notice that's probably correct because that's in all the answers. Well, half the answers. If we take 10 to the 12th times 10 to the 6th, remember, if we're multiplying two numbers with the same base, we can just add the exponents together. So 10 to the 12th times 10 to the 6th is just going to be 10 to the 18th. And this is times. Okay? And this isn't proper scientific notation, though, because remember our rules for scientific notation say that our decimal has to make a number between 1 and 10, which means we need to move our decimal over one place. If we move our decimal one place to the left, we have to do the opposite to the other side, so it balances out. So we get 1.892 times 10 to the 1 more than that, 19. Okay, because what we did here is we said we divided this by 10, right? And then we multiplied this side by 10, and that balances it out, right? So this gets smaller, this gets bigger, but we stay pretty balanced. So here is our answer right there. Alright, number 9. Which shows them from greatest to least? This is children's questions. The only thing we might not know is the square root of 11. So if we type in square root of 11, if I can find my square root button. Ugh, my calculator's too advanced to do that. So we get 3.31. So greatest to least, our biggest number is 4.1, followed by 4.065, followed by 3.3, and 2.5. That's it. We're done. I don't want to do any more of that. Alright, here's a good question. Which function represents the number of small squares in figure n? This is kind of like what we did with the cubes, in that we could, make a table and say x and y, and well, figure 1 has 3 squares, and figure 2 has 8 squares, and figure 3 has 15, and sort of find the pattern and look at the second difference. But we can think a little bit smarter than that. Let's do that instead. So if we look at our pictures, they all kind of look like what? They all kind of look like a square, except it's missing one piece, right? So this one here, this is 2 squared minus 1. This is 3 squared minus 1. And this one here is 4 squared minus 1. Alright, so we look at our answers, we get n squared minus 1, and this one's minus 1, so we can assume one of those is correct. And then we just think about what is the difference between these two. Why would this one have plus 1? Well, if we look at n is the figure number, well, 1 is not what we put here, 2 is not what we put up here, and 3 is not what we put up there. It's always 1 more than that, which means our answer has to be n plus 1 squared minus 1. And if we had our table and we brought it back, x, y, 1, 2, 3, 3, 8, 15. If we tried that, if we said like this one, if we did 3 plus 1 is 4, 4 squared is 16, minus 1 is 15. So that works too. Alright, that's it. Number 11. We've seen problems like this, and this one's even easier than usual because all it wants is the equation for the area. So really we're just saying what's 2x plus 1 times x. So we distribute a little bit, we get 2x squared plus x. And that's our answer. Hooray. Number 12, factor this. So people are asking about this one. This one's a little bit different. And that if we look for a greatest common factor for all 4 of those terms, it's not there. We can't do that. So what if we split it up? What if I try to mess with the left side and then I try to mess with the right side? So we look, what does everything on the left have? Well, everything on the left has an x squared. So what if I factor that out? So we have x squared, and what's left here? We'd have x, just x, and then we take the x squared out of 3x squared, so that's just going to be 3. And then what we're going to try to, and hopefully what we'll get is that we're going to factor out something that'll leave x plus 3. And if we notice they both have a 2 here, this works out really, really nicely because we get x plus 3. Alright? And now we get into some like next level factoring stuff here. If we say here is term 1 and here is term 2, and we say what do these two terms have in common? You say, well, they both have x plus 3. So if we factor out the x plus 3, so we're going to take that out. And what we're left with is x squared plus 2. And for some reason they always put these in parentheses. Doesn't really matter, but oh wait, it does matter. I'm lying because this is being multiplied. I'm sorry. Ugh. So x plus 3 times x plus x squared plus 2. which gives us our answer H. My bad. Alright, number 14, which one? This one's just kind of a lot of work. So if you get a compound inequality, all that means is you're going to have to solve two different inequalities. So if we solve this left side, we say plus 5 plus 5, we get negative 6x is less than or equal to negative 10. We divide both sides by negative 6. We get x's. Since we divide by a negative number, we flip the sign. 10 over 6 is the same as 5/3. Negative and negative becomes positive. So there's the left side. Now we do the right side, same thing. So if we minus 28 from both of these, we get negative 3x. It's greater than or equal to 52 minus 28 is 24. Divide both sides by negative 3. We get x. Again, negative. We flip it. 24 divided by 3 is negative 8. Okay, so here are two answers. And if we put this on a number line, here is 5/3. It's more than that. Here's negative 8. And it has to be less than that. Right? So we're not going to have one of these. This isn't going to work. This would mean that it's the opposite. It would mean it would be everything in between those two, but that's not what we're doing. So that's not it. That's not it. So we look at our answers. X is less than negative 8 and 1 2/3, which is the same as 5/3. So our answer is going to be H. That's it. Observe this relation. Okay. Oops. Oh, it's down here. And find which of these that does not match that. Well, hopefully you can look at this, recognize, hey, this is a pretty good V, which means that this is going to be, anytime you get a V, it means it's the absolute value of something. So if we look at our positives, we have, I have to make the chart because the chart's right here. 0, 0, negative 1, 1, 1, 1, negative 2, negative 2, 2, 2, negative 3, negative 3. Okay, so we get an equation that looks kind of like y equals, and really it's just the square root of our square root, the absolute value of x. Okay, so this is going to be the same as that, just written differently. This, again, same thing. The only one that doesn't match is this one. Hopefully you're able to recognize that right off the bat, that if this was x squared, it would look like a u, not like a v. Okay? So that's it. If you got one of the ones that had the second half of this, if you worked them all out, good for you, but you didn't have to. But you're ahead for later, so good job. Alright, good night.